Welcome to the view into the system, today with our 3D X-ray inspection system X-Line 3D. My name is Andreas Türk and I'm the product manager for the X-ray systems at GÖPEL Electronic. So let's have a look into this machine. First, the outer appearance. The footprint of the machine is only 1,60 m times 1,60 m at a weight of 2.6 tons. The whole machine is covered with lead and the liquid leakage is only 0.5 microsievert per hour. That means you can use this machine 24/7 in your inline production. So let's look into the machine. During the design of the machine, we had a close look to the accessibility. That means we have two doors in the front and one service flap in the front and one in the back. The whole machine consists out of 3 independent chambers with 3 independent belts. Those chambers do have internal shutter modules so that no radiation goes out of the machine when a PCB is loaded and inspected in parallel. The 3-chamber principle gives us the opportunity that we do an X-ray image acquisition here in the middle part, and directly after the last picture was acquired, the machine is moved out of the X-ray beam into the post-processing conveyor. And this is important to achieve short cycle times, because now image acquisition and the post-processing is done in parallel. Post-processing means MES export, calculation of the images, reconstruction of the images and the algorithms, as well as measurement and picture export. In this position here, we have the tube mounted on an Z-axis. So the movement can go up and down to change the resolution. Typical resolutions that we achieve are between 10 and 20 micrometers for an inline usage. The top clearance is about 20 till 40 millimeters, and the bottom clearance underneath the board is fixed with 65 millimeters. As an option, you can include either an internal code reader or an external code reader directly in front of the machine. Next to the code reader, we have an 2D laser sensor. This sensor is important when you are working with 3D X-ray technology, for instance, for inspecting double-side assembled PCBs. You need 3D to separate top and bottom assembly. And now imagine your board is warped. So when you do a 3D slice now, it's important that you inspect in the correct height. That's why we use either the laser or software algorithms to compensate the warpage of each board when you're working in 3D. Underneath the tube, you have the PCB clamped top side down. And those clamps are mounted on an X-Y axis system. So in this case, during image acquisition, only the lightest part, the PCB, is moved, not the heavy tube and not the heavy detector, which is mounted fixed here in the bottom area of the machine. The detector, called multi-angle detector 3D, allows a scanning image acquisition in 2D, 2.5D and 3D. Scan means that we are much quicker than a standard stop and go image acquisition using a flat panel detector, for instance, and so we have short image acquisition time. Due to the fact that the 3 technologies, 2D, 2.5D and 3D, are acquired in parallel, the programmer can then choose up to his needs the perfect technology to detect all his failure and to achieve a good failure coverage. The whole machine is equipped with a digital maintenance concept So we have implemented counters for amount of transports, amount of access kilometers, amount of X-ray emission hours, and based on those counters we make suggestions for a maintenance. So preventive maintenance concept in this case. The service and maintenance app is not only the only one software that we give to you. So we have a mighty software package, for instance an offline programming software, very intuitive and wizard-based, as well as an app and touch-based machine software. And also the machine includes into the world of Industry 4.0 using different MES plugins and standards like Hermes or IPC-CFX. I hope you're interested in this machine, and if you want to get some more details, some more technical data, don't hesitate and watch our short webinars. I thank for your attention.